Hey everybody, welcome back to the last part. Here we're going to dive a little bit into more detail about these numbers, these quantum numbers that we get when we solve Schrodinger's equation. And so we're going to start off with the principal quantum number. Remember, this number details the size and the energy of what's known as an orbital. These are just a prediction where electrons will be around a nucleus. L is the angular momentum quantum number. This will determine the shape of the orbital. And then the magnetic quantum number we'll really see in the next chapter. And so we can use orbitals to explain, right? Bohr came up with a model on why you see wavelengths. We can use orbitals to help explain the atomic spectroscopy results. Now, how can we do this? So what we're going to do is we're going to look at some equations on the board. All right. So here's the equation to calculate the energy level from an electron. And what we use is what's known as Rydberg's constant. Rydberg's constant is negative 2.18 times 10 to the negative 18th joules is equal to 1 divided by n squared. N is the quantum number. So if we look, here's an n of 1, and a 2, and a 3, and a 4. If we just plug these into this equation, we can calculate the energy of that orbital. And so what we see is that as we go up in orbitals, the energies usually get less and less and less. And the reason why is you're getting farther and away from the nucleus. Here is a way that we can calculate the energy change. And what you do is, again, it's final minus the initial. So it's this Rydberg's constant, negative 2.18 times 10 to the negative 18th, times 1 divided by n final minus n initial. Right? And so what happens, the final one is where it goes up, 2 minus wherever it comes back down to, and that's the energy. And we showed you in part number 2 how you can take energy and use it to calculate a wavelength, right? And so what they do is they can find out the energy and how it can translate to then to the wavelength of the light and what light will be released. And so that is n, right? This is n. It tells us the energy of the orbital. And the overall size of the orbital. Now let's look at what L tells us, right? Because each orbital has a unique shape. As you can tell, there's a variety of different shapes. As we change the L's, we will need to know what L corresponds to, what shape it corresponds to. These shapes are important later when we talk about different covalent bonds and things like that. One of the ways that we're going to also teach you how to calculate L is just by looking at N. You can also notice that these shapes are just probability maps, right? This is a probability of where we can find the electron around an atom of a nucleus. So s orbitals have the lowest energy, right? You can see they are spherical. They are spherical. Notice L for a spherical for an s orbital is 0, right? Is 0, right? So if you see an s, you know that the L is equal to 0. Now this is an n of 1, so we can have an L of 0. Notice L minus 1 is, so let's say we go to n of 1, right? We can only have an L of 0. We cannot have an L of 1. We cannot have an L of 2. There's just not enough energy contained in that orbital for it to hold those different types of L's, those different types of shapes. So this is L of n of 1, right? So this would be a 1s orbital. We can go up in energy by going 2s or 3s, depending on what the n is. Well, again, we're just showing you shapes. We're showing you energy. We're talking about energies. We're going to talk about these in a little bit more detail in the next chapter. Now, just to let you know, the number of sublevels, we'll talk about sublevels and things, is equal to n. The number of orbitals, right, that you can have is 2l plus 1. And then the number of orbitals in the level is n squared. So just write those down. So again, I just want you to write these down, and then we'll look at a graph, and I'll explain to you what these mean. The number of sublevels equals the n. Number of orbitals in the sublevel equals 2l plus 1. And then the number of orbitals in the total level is n squared. Now we'll come back to that when we look at the graph, because it will make sense. I just want to bring it forth here because we'll start talking about L's, and it'll make more sense, especially when we start talking about how to fill these orbitals. So p orbitals are the next level, right? So we have s is L of 0, p is L of 1. P's look like these dumbbell shapes. So again, the lowest, so p, we cannot have a 1p, because remember, it has to be n minus 1. And so L of 1 is p, we can't have a 1, 1. We just can't, there's not enough energy. But we can have a 2, 1, right? So we can have a 2p. Let's talk about D's. D's, we add another 2 lobes on there. They contain 5 of them. There's 5 orbitals total when we talk about D's. L is equal to 2 when we talk about the D orbital. And then finally, with the F orbital, we have L equals 3. The lowest, or the highest, the lowest n that you can have in F is 4, right? Because it's n minus 1. So we can't have a 2D, right? We can't have a 3 or 3F. We can't have a 2F. Can't have a 2D either. But we can have a 4F. And the reason why is because of just the energy level. And you can see that there are some really nice shapes in the F orbital, depending on the spacing and the geometry and where these are. So why do we have, so for a P, right, why do we have the 2 lobes? Or what do the 2 lobes represent? The 2 lobes represent phases, right? Because we said electrons behave both particles and waves, and so they have phases. And so just to show you, this is just showing you a phase, whereas an S only has 1 set. So there are no really phases, whereas a P, then you add another phase. So you can see the blue and the red. We're not going to really focus on that. I just want to bring that out to you. So how do we depict orbitals on paper? So this is where we can keep track of orbitals. This is going to be in the next chapter. Abundantly, we're going to be doing this, filling orbitals. So let's go back to our rules. Number of sublevels we said was n. If you look, a sublevel is a box, right? So if you look at a box, so 1s, that is a sublevel, 2s, 2p, those are 2 sublevels. We said the number of sublevels equals n, right? This is just a way we can check our work. The number of orbitals in the sublevel, which are those little clear boxes, right? Those are the number of orbitals, where we said 2l plus 1 in a sublevel. So we have a 1s, right? In that gray box, we have 1s. L equals 0 for an s orbital. So it would be 0 plus 1. There would be 1 orbital. So for all s's, there's 1 orbital. P, right, we have 1. So it'd be 2 times 1 is 2 plus 1 is 3. For P's, you always have 3. For D's, you always have 5. And then what we can do, the number of orbitals in the level. So if you have n of 2, right, you would count the little white boxes. We have 1, 2, 3, 4. That's n squared, right? So again, these are just ways that we can talk about it. M of an L, right? M of L is that spin. There's ML is just another angular number. It's just another quantum number that we can use to designate these orbitals, right? So for S's, it's always 0. For P's, it's always -1, 0, +1. And then for D's, it's -2, -1, 0, +1, +2. What we're going to find out is that in the next chapter, we will be able to accurately predict where an electron is in these orbitals, right? Obviously, it's a prediction, but we'll be able to, I'll be able to give you some quantum numbers, and you'll say, okay, I know what that electron is. That electron is right here. Now, why do we care, though? Why do we care about the shapes and the orbitals and electrons? Well, because electrons are how things interact with each other. and bind with each other, but it also explains why we depict atoms as circular, right? If we have all these nodules and nodes there, it's really hard to draw an atom with all that. So then what we do is we just kind of encapsulate it solely in that s orbital that encapsulates, the tough word to say, everything that's in there. And so this ends chapter number 8 about the quantum mechanical model about electrons. Hopefully you guys enjoy this. If you have any questions as you work some of the math, if you do some of the problems, especially in the lab, please let me know, and I will be sure to help you answer those questions.